Hi, today we're going to talk about soils and excavation. What are soils and why do we need to talk about soils? Well, soils include everything from silt to rock. That's the gravels, the sands, the silt, and the clay. And most soil is a combination of two or more of these. And each unique combination, along with other variables such as water, gives that soil a specific bearing capacity. So, what is bearing capacity? Bearing capacity is the load that the soil can support. Loads are usually measured in pounds per square foot or in kips per square foot. And a kip is 1,000 pounds per square foot. A load is the weight of whatever we are building and everything that goes in or on that structure. The dead load is the weight of the structure. The live load is whatever goes in or on the structure. So it's people in school, cars on a bridge, snow on the roof, desks in the office. We know the weight of what we are building and how that weight is distributed. We need this information to design the structure of the building and the weight of everything that goes in that structure. For example, a bridge is a huge structure and can have a large load on the structure, but the weight on the structure is on very few points. It'd be the end points of the bridge and the columns under the bridge. Let's look at the application of what we just talked about. We can calculate the weight of a building or a load on any particular column in a building. We can test for the bearing capacity of the soil, and we can design a footing that will support the load. For example, we have a building that weighs 1,000 kips. The building is supported on 10 columns. The weight or load on each column will vary with the column's location in the building, but the total will be 1,000 kips. Each column footing will be designed for the load on that column. So let's look at a graphic illustration of what we just talked about. We have the ground level and the soil under the ground. Now we're going to put a load on it. The blue arrow illustrates the load, and the red is the building column. Now, if there's enough bearing capacity to be able to hold up that load in this soil, we'll be fine. Now, the bearing capacity has to equal the load on the building. If it won't, the bearing capacity is less than the load, it's going to sink. So what we're going to need to do is to build a larger foundation, a larger footprint, because we know how many kips are going on that column, and so we're going to have to spread that weight out over more square feet. So we got fewer kips per square feet to be able to hold up that load. In order to improve the bearing capacity, we can also add additional gravel or more stable soils. And we can also do compaction, which is dependent on the ability of the soil to be compacted. Some soils compact better than other soils. The chapter goes on to discuss the classification of soils, testing methods for classifying soils, what is the standard bearing capacity of certain soils, and then it goes into some discussion about excavations. Excavations require support during construction to support adjoining areas. The most frequent are steel sheet piles, soldier piles, or contiguous board concrete piles. Each of these requires installation before the excavation begins. After reading the text, watch the videos and the additional resources to have a better understanding of the use and installation. Soils and excavation are the beginning of most construction projects. The understanding and ability to communicate with trade professionals is a requirement for construction professionals.